What is up, guys? Welcome back to Vanover Machine and Repair. My name is Kyle, and in today's video, we have a brand new machine in the shop. Super exciting day. Behind me is a Lucas 441B boring mill. And some of you guys may have noticed this in the background of some other shots. And this machine has been sitting for about 9 months, but today's the day we finally tear into this beast. Now, if any of you guys have machine shops with old equipment, you know that sometimes machinery can sit around for quite a while, especially if you're trying to find equipment on a deal. You might buy it, you may not have the time, you park it, and when you get around to it, then you jump into it. This one is no different. Currently, we're in the middle of our Lion lathe project, and I tend to work on one project at a time so I can be focused and get those things done. However, our queue in the shop has been filling up with work that is designed for this beast. So we are going to temporarily pause the Lion lathe project and just spend about a month or so on this machine, getting it up and running so we can put it to work. So as much as I would love to kind of dive in and do a full restoration, honestly, the value for me in the short run of getting this up and making some money with it exceeds having it in pieces in my shop for 2 or 3 years. So with that being said, let me bring you in closer and tell you some of the details of the machine. Jumping right in, some facts, figures, and numbers about this boring mill. So this machine weighs 31,500 pounds. So if you're curious, moving it with your typical 2, 3, 4, maybe even 550 is a little bit out of the realm. You really need an 18-wheeler with a drop deck and a huge forklift to maneuver it. So it can be quite pricey, which we'll touch on in a moment. As far as the capacity of the machine, it is a -72, meaning that it has 6-foot travel on the head. It has 6-foot travel side to side, and I believe the saddle on this machine has 54 inches of in and out travel. The quill has 24 inches of travel in and out, and the motor is a 25 horsepower. So as far as cost, so typically for a 4-inch boring mill like this, these range very widely in cost, but generally I see them between $10,000 and $20,000 depending on condition plus rigging. Now I touched on this a minute ago, but rigging for these machines is the deal breaker. I've seen machines like this go for $1 because they cost a ton of money to remove and to get into place, and I've seen them go for over $100,000 easily. Just depends on the condition of the machine. But if you were to go and buy a new version of this, I'm sure it'd be over $150K. So that's just something to be aware of. Now I paid $600 for this machine, which I do believe is a steal. At the time, it was a featured lot on BidSpotter. So it had a video, they tried to clean it up a little bit, it had a pile of tooling, has a brand new-ish, new-all DP700 DRO, and they showed the operation of the machine. So I think they were expecting to get quite a bit more out of it, significantly more, because it was a featured lot, but hey, I got lucky. Now, where I didn't get lucky was moving this bad boy, and I knew this would be the case. So I paid $600 for this machine, but I paid $6,000 to get this machine moved from Indianapolis here to Chicago, unloaded off an 18-wheeler, and rolled into place. So if you're curious and you're looking at something like this, keep in mind the rigging and the moving is what's going to get you, especially with the weight. Let me bring you around to the back side and we can talk about the electrical and what we're going to need to get this bad boy running. So the first step in getting this guy running is going ahead and just getting the machine cleaned up. I've been using it to store a bunch of junk, so I'll go ahead and off camera, move all that out of the way, get the floor swept up, and just in general, tidy up the area. The next step of the phase of getting this guy powered up is the electrical. Now on a machine you come from an auction like this, sometimes the electrical can be a little bit hairy. On half the machines that I've had, they've been labeled from the factory or wherever I buy them, and the other half, it's kind of unknown what voltage they are. So this machine specifically had no indication of the voltage no stickers, no labels, no nothing. I opened the massive panel on the back, and there was really not a lot of great information. I seen 120 volts on some transformers, 220, but my gut was really telling me that it was 440 just based on it coming out of a factory. And I am very fortunate in my shop. I do have 440 three-phase, 220 three-phase, and single-phase 120 and 220. So whatever it needed, we have, which is excellent, but you really don't want to wire this up wrong without verifying it. So the best thing to do to figure out what voltage you need is to take the main motor and to remove the wire cap and count the wires and see how it's currently wired up. So off camera, I went ahead and pulled that motor cover. It's a really tight, hard to film location, and did indeed verify that that motor is running on 440 volts, which is kind of what my gut was with this machine. So now that we know that, I need to go and run a brand new line in my shop about 150 feet over to the left, all the way over to the machine, and then into the actual machine, and then we can get it powered up. I'm not going to show you that because I'm not a licensed electrician, but I will kind of give you a lay of the land of what we need to do to make it happen. It's a little difficult to show this because the machine is against the wall, so I'll overlay a picture of this giant electrical panel. But we have a huge electrical panel that's maybe like 4 foot by 4 foot on the back of this boring mill, and there is a ton of stuff in there. We have contactors, relays, transformers, timers. We even have some tubes in there, and frankly, I don't know the condition of most of it. We did see a video of this machine running, which makes me a little bit more comforted, but just looking at the condition of the machine, I would say overall it's probably in the medium to low condition wise. There's definitely boring mills that are more clapped out than this one, but there are a lot of boring mills that are probably in better shape as well. So electrically wise, we're just gonna run our conduit and set up our panel over at the box for our 440, plug this guy up, and then kind of take it as we go. So I'm expecting that it's gonna fire up, but I'm also expecting that we are gonna have some gremlins either electrically or somewhere else in the machine. So what I'm going to do is I'm going to spend a day or two setting my conduit up and getting my wiring done, and then I'll bring you back once this machine is thoroughly cleaned up from the junk, wired in, and we'll get this guy fired up for the first time. Well, a few weeks have passed and we got all the electrical set up. I got my power run, got it going into the box, and everything should be set. While I was doing that, I realized I needed to get air over to this machine, so I went ahead and ran air piping as well and set up a regulator, and while I was at it, I ran another 220 outlet and a 110 outlet and another 440 outlet. So the electrical got a little bit out of hand pretty quick, but I figured since I'm over here anyway, I might as well do some of that infrastructure stuff since I'm going to be working back there and doing that anyway. So with all of that wrapped up, I went on to just getting this area cleared. As we talked about, it's been being used as a shelf. So we got everything cleaned up. I just went around and kind of wiped down the ways from all the dust. And then we went ahead and put on this top beam that holds the DRO and kind of cleaned up some of the wires, ran the air over to the machine, and we are ready to get this bad boy started. Now I did pop the breaker and nothing went bad, so that's good news, but I have not started this machine. So I'm going to give you kind of a B-roll shot of the wiring in the air, but for the most part, we're ready to turn this on. Now a little bit of a disclaimer, I have zero idea how this machine works, and I don't have any problem saying that. We're going to learn as we go like everything else, so you're going to get to see me flip it on and react positively or negatively. And we're going to try a couple different switches. We do have a beam blocking the head from coming down. They did that for transport, so we need to get that out of there. And we have some cleanup to do, but before we do that, I just kind of want to see what works and sort of make a list of what is broken. So let me go around to the back, flip the switch, and we'll turn this bad boy on. Here we go. Okay, sounds pretty weird, but I don't know what to expect. We got some kind of buzzing in here. Kind of sounds like a gear or something rattling around. Maybe it's like an oil pump. Not sure yet. We'll figure it out. All right, it sounds like the rattle is coming from in here. Sounds like maybe we have a gear pump running. Hard to tell. We do have a pretty loud transformer hum in the back, but that may be normal. I like my machines to be quiet, but hey, it is what it is. Yeah, let's get this guy flipped on. It is possible that we have the motor wired in reverse. That's something you need to be aware of anytime you wire anything up. Not a big deal. You just reverse any of the two leads, but I don't know which way is the right, so we'll figure it out. Either we'll be lucky or unlucky. All right, maybe forward. Okay, that did nothing. That's a rapid. Spindle. That doesn't do anything. That doesn't do anything. That does something. I reversed 2 of the wires on the hot and then checked the fuses. Everything's good, so let's give it another shot. That might sound better. I don't know, it's hard to say. Nope. All right. I need to do some diagnosis and then we'll kind of go from here. I'll update you once I know something. All right, after only about 20 minutes of messing around, we figured something out. I thought the spindle start was over there, but apparently it's over here. So I thought this was the transmission, but I think it's the spindle start. So when I pulled out on this, thing started up. Thing is loud, real loud. Let's see what this is. All right. That's something. All right, the spindle is spinning. This thing's a little loud. Let's see. I would like to get the head going up. Saddle, up. Now the question is, how do we get it going up? We spent some time messing around, trying to figure things out, and ultimately I called Josh over at Topper Machine, and he provided some really great insights. So I've got the machine running. I figured out how to operate everything. It took me a couple minutes. It wasn't initially intuitive, but I got the hang of things. We do have a list of problems that we need to tackle, but it's manageable as of right now. I'm sure we'll find more once we get in deep. So the first one that's obvious is we have an air leak. You can probably hear it, but it's just a bad hose in the back, so that'll be easy. Also, not all of the air features work on this machine. We're supposed to have a pneumatic lock for the head, for the table. We're supposed to have, I believe, an air lift, meaning it maybe possibly lifts the table to make it a little bit easier to move. Just based on the airlift sign in the front. I don't know that for sure. And then we have a power drawbar. Now, if I were to pick all of the ones that I want to work, the power drawbar would be my preferred one, and that is the one that is working. The air locks may not be necessary, especially since we have a manual lock, or at least that's what I think this is for the table. So we need to diagnose that. Also, it doesn't look like we're getting oil pressure here at the spindle. That's really important. I talked to Josh about that. That is a top priority. And this gauge is out of the housing, which isn't a great sign. And I do hear a loud noise back there. Sounds like a motor kind of rumbling. So there's that. Also on the back, we have a pump, and I can't feel it pumping anything. So just confirming with that, that's going to be something we need to tackle. As far as the movement of everything, everything moves and goes in the right position. However, I can't get the saddle to move in and out. So I think what's going on is we have a problem with the limit switch, so I need to tackle that. Overall, pretty excited that we got this bad boy running. I was a little skeptical in the beginning there. It's running. We could take some cuts with it as is, aside from not being able to move the saddle. But we do want to get oil flow, and we want to get the saddle working. So I'm going to take some time off camera to kind of do some investigation, and then we'll bring you back once we make some progress and show you kind of what we're doing. So, yeah. Well, that escalated quickly, and it often does. So just real quickly, we had an issue with the limit switch. I couldn't get the carriage to move, but we were able to figure out the power feeds and everything electrical everywhere else. That pretty much left us down to the last and probably most important issue that was obvious initially, which is the oil pump wasn't working. So I started out, our gauge was popped out of the housing here. We pulled this plate. Some of the noise that I was hearing, kind of that grinding noise I mentioned in the comments or in the beginning, was where this gear was basically running the oil pump. The oil pump was running dry. There's a significant amount of in-play in this motor shaft, and the bronze gear is pretty pointed, so it's pretty worn down. So we started there, we figured that out, we took off our gauge, and we had no flow for oil. We looked at our oil site, and it looked like we had plenty of oil. So I was thinking I was going to need to do a new oil pump, et cetera, and then it occurred to me that I needed to check to confirm that that oil site was accurate. And when I pulled the drain plug, nothing came out except for some water and a few drops. So at that point, I knew our pump was running dry and we needed to investigate further. I really wanted to see down into this cavity here so that way I could know what's going on and, more importantly, get it cleaned out if it was dirty. So I ended up pulling a cap on the back over here to see if I could see down into this cavity, and just my luck, when I pulled that cap, there was a keyway on a shaft, and the shaft was pointing down. I dropped the keyway down into this gearbox, and so it was from that point I realized I needed to create access to get that keyway and hopefully also be able to inspect what's going on here, and that kind of led us to this point. So I popped off the sight, and I was able to come in here and pick out the keyway with a magnet and verify that it was pretty much bone dry in there level-wise. And then I went ahead and removed this cover and the front cover just so I could get an idea of how dirty and disgusting it is in there, and sort of proceed with cleaning that. So that's where we are at. Now, unlike some of my other videos, I'm not going to take you step by step. We did that kind of nut and bolt, step by step with the Lion. And frankly, this machine just needs to get up and get it running. It's not a full restoration. It's let's get it functioning excellent and just clean it up and put it to work. So I'm bringing you along as I do this stuff, but I'm not going to bore you with me cleaning this out. I'll just kind of give you updates as we go. But the inside of this is really, really disgusting. Not only is it super muggy and grimy, this pump hasn't been working for a long time. And the pump might be fine, but what we need to do is we need to come in here, we need to clean out all this garbage. I'm probably going to remove this so I can get to this section of the gearbox because there's a wall right here. And then we need to go through every single line, clean it out, every single meter. There's 4 here, 6 here, 5 here, 3 there, 6 there. So you can add that all up. That's about 40 different ports that we need to clean out, and we have meters on about half of them or 3/4 of them. So we're gonna be probably ordering new meters. You can try to clean them, but they're cheap and it's not worth it. We're probably gonna be doing something with the lines, trying to reuse them. We'll be replacing some lines where we can or where we need to, and we'll be getting all of this cleaned up, hopefully on both sides, doing a new sight glass and making sure we have clean oil flow. So that's kind of a rundown of what we're gonna do. It's gonna be super messy and boring, so I'll bring you back when we get all this cleaned up and sorted out. A little bit of an update here. We're midway through getting this all cleaned out, and I just got off the phone with Vanover, the pump manufacturer and manufacturer of the metering units for this, and I figured I'd just kind of update you guys on what I learned because it is quite interesting. So haven't seen a lot of content on this, probably because it sucks, but it is good to kind of get out there. Anytime you're working on a machine like this, obviously you want to get everything cleaned up out of the bottom. The pump is not going to be able to pick up sludge. So we went in here and we cleaned everything out. I still have a little bit of kerosene in the bottom, but for the most part it is pretty dang clean. So once everything is cleaned, then the process is disassembling each of the manifolds, taking off the meters and cleaning out each line. I had lines on the top here that I removed. I blew kerosene and air through each of these lines and confirmed that the line was clean and open. And then when it comes to the meters, basically the meters just limit the flow. So whoever engineered this oiling system figured out with X amount of pump, you need X amount of flow at each bearing point or way, and they use little devices called meters to basically regulate that flow. So oil comes through, it comes to a manifold, and it goes to the different areas in a regulated manner. Well, those meters get easily clogged because they basically meter the flow by limiting it. And they use that with a little brass plunger and a brass screen, and some of them also have little pieces of felt inside to kind of lessen the flow. As a result, those get clogged. Some people have had luck cleaning them, but at the end of the day, I'm just going to replace them. I don't want to come back here and redo this, and I don't want to do a what if. I know without a doubt that we have good flow from the hose to each point. So I know if I replace the meter, it'll be perfect. And then obviously we'll make sure we have a clean pickup and a clean filter. And I just want to know at the end of the day that we are going to have good oil flow. Mostly for the spindle bearings, but secondarily for the ways, and obviously for the gears probably third. So after talking with Vanover, we figured out that the pump that was in here is actually installed in 2000. They're really friendly, helpful guys, and they have a serial number system that allows them to know which year the pump was made. So that's really nice for us. Even though it wasn't working, you know, it's not that old compared to other equipment. It's not original. It's about 20 years old, which isn't too bad in my opinion. So that's kind of cool. Those pumps are about $1,400, so they're rather expensive. And then obviously the meters are about $20 each, and we need 20 of them. So as you can see, this kind of adds up quickly. So what my goal is to come in here and to get this upgraded without spending too much money, but doing the right thing. So in that case, we're going to do the meters, and I'm going to see if I can either rebuild the existing pump or come up with a creative solution there, and then we'll be replacing that motor. That motor's pretty cheap, and it has a lot of in-play. So overall, the system is coming together. It's just a lot of elbow grease and being very tedious, but I thought it was interesting talking to the folks at Vanover. They have a lot of cool information, and we're getting all of this. Several weeks have gone by, and I want to update you with all the work we've done. It has been super busy in the shop, so I've just been kind of ordering parts, kind of working on this here and there, And when it comes to doing this type of stuff, it's usually expensive and slow, but well worth it in the end. And this kind of has been no different. So I just want to give you a breakdown of what I've done over the last couple weeks, because we've done a lot. So the first thing we kind of last left on is just getting everything cleaned up. I actually found an access panel in the back on the machine, and lo and behold, that area had tons of gunk as well. So we got that panel off, we got all of that stuff cleaned up. So every cavity where oil sits is now clean, which is extremely important. We went ahead and painted the inside of that white with enamel paint, so it's real hard. Not necessary, but I did that because everything was out, and being white, it helps me see that everything is nice and clean. So once I get everything reassembled and I got my good oil flow, I can come in here, start the motor, and just check to see if I got any leaks. Everything will be really easy to identify. It's more functional than looks, so that's pretty cool. We went ahead and installed a new motor. So I was able to source a motor that is a 1/15 horsepower. Unfortunately, they don't make the 1/20th in the same configuration, but this will work good. I went ahead and rebuilt the pump, was able to source the gaskets, and then we did test the pump using a gauge and verified that it is making full pressure. We went ahead and 3D printed 2 gears. One of the gears is originally phenolic on the motor, so I think these gears will be fine. If anything, maybe run a little bit quieter. And I also changed the gearing. According to Bijur, this pump is good for 1,000 RPMs, and with the existing ratio is running about 750. So I manipulated the gears a little bit so I could run it at a higher RPM and hopefully get some better flow. So now we're about 550 RPM. So we'll see kind of how that works. Let's see, I have a list here because we did a lot. We also added a filter. So there is a filter already on this system. It is a plate style filter. And even though those do work, they're pretty old school. And with all the work that I'm doing on getting the oil system cleaned, I really didn't want to chance clogging up all these meters since we did go ahead and replace all 20-something of them. So I added a aftermarket Bijur filter that's good for 10 micron. So our oil flow comes out of one filter, it goes into the next before it enters the pump. So that should make sure everything is nice and clean. We went ahead and scaled the head. So we went ahead and just got this head fully stripped of paint. Now, why did we do that? This is not going to be a restoration with a top priority on paint job. I don't even know that I'd call it a restoration. We're just trying to get this machine operational and working within reason as best as it can be. But for me, getting the paint removed allows me to easily see what's going on when something has been repainted 100 times and all the screws are painted over and switches and knobs. It's really difficult to see what's going on. So stripping the paint not only allows me to paint it once just by hand, nice and quickly, and to not have it look super gummed up, which is nice, but also allows me to really see what's going on. And I can't tell you how many times I've missed something, whether it's a screw or a port or something, just because it was covered with paint. So that's why I went ahead and scaled that. I also scaled everything above this area. That way, over time, as I'm finishing out the rest, I'm not dropping any paint chips into here. So everything basically above this is scaled. And then once I get this moving, I'll move it to the top and finish from the top down. So we got all that taken care of. I don't know if you noticed, but we got the head and the back on, both sealed up. Went ahead and adjusted our belt tension on that. So the head plate is good, and we had to address some things over there, very minor. And then same thing for the back, we're replacing some bearings, nothing too crazy. The other thing that I want to mention is we went ahead and eliminated some wiring that we didn't need that went over to this Travadial style setup. So it makes the wiring a little bit more clean and neat. And then I bought some machine tool wiring. So when we go ahead and clean up the wiring. We don't know how deep we're going to get into that, but I have the proper wiring. But for the most part, the wiring in this area is now pretty cleaned up. We went ahead and I know I touched on the clutch in the back. I damaged that basically by removing it. There was a wire that was torn or close to being torn, and so I tore the wire, or it was torn when I removed it. So I sent the clutch out for a rebuild on the coil. So that'll be coming back to us shortly, and that clutch is for the high-speed activation on the spindle. So overall, we have done a ton of work in this area. It may not look like it, but most of the work is for good oil flow so that all of our bearings can stay lubricated, and just making sure that everything is working properly. Now, I am sure, unfortunately, that we'll get this back together and there will be some bearings deep in here, hopefully not the spindle bearings, that do need to be replaced or are noisy, and that just is what it is. I'm not trying to tear the whole thing apart. I'm trying to get it running. I'm trying to get it running cleanly and circulating clean oil. So at some point in the future, if we do have any deeper bearings, we may have to take the head off and kind of address that. But for the most part, everything should be clean. We should have good oiling. Anything obvious that I've taken off, we have addressed, and just really got this to a much better situation. The head is going to be more sensitive than the gearbox because it has spindle bearings and it has a quill. So I really just want to make sure the head is operating to full capacity and operating properly. So that brings us to kind of what is next for this step here on the head, and kind of where we're going to go from here. So let me give you kind of a wide shot and kind of show you what the next step is. So now that we got all this stuff dialed in, and one more small note, we went ahead and got this squared away. This is just the front plate. I went ahead and disassembled and cleaned this, mainly because our hand wheel that goes on here, it was pretty beat up, and so this face was all destroyed, and I'm going to be 3D printing a new handle or fine feed wheel, but I didn't want to put it on here with a very rough face, so I took this apart, faced it, and then I went ahead and just cut 2 keyways. Originally it was held by a pin, but because we're 3D printing this handle, that's not going to be sufficient. So a double keyway 180 apart will be enough kind of grip so we can use a 3D printed press fit handle and it will look real nice. So we got this squared away. That was pretty straightforward stuff. So now that we've kind of talked you through all of that we've done, what is next? Now I would love to get this stuff assembled and back together and test the oil flow, but I've run into kind of a couple issues that I've probably alluded to, and that is we have several broken parts that need to be addressed. So those parts exist in the turntile or turnsile or turntable or whatever they call it. It's kind of a weird name they have for this area. The previous owner of this machine was very rough. There's lots of damage. We've corrected lots of issues, but in this region specifically, there are 2 sun gears and an idler gear. The idler gear was missing. The sun gears were chipped. Those parts are cast iron, and we have a giant brass or bronze gear that is also damaged. And so in order to put this together and make sure everything is sealed so we can add oil and test our pump, we need to get all this on. And in order to get all that on, we need to square away what we're going to do with all these broken parts. Now, originally it was just put together as it was, and that does work functionally, but you lose some of the feeding features because it's missing some parts. So we are going to be addressing that. So just kind of stepping back, because I know there's a lot of information and talking. When I approached this video, what I wanted to do is kind of show you the machine and kind of give you an idea of just some basic maintenance that I've had to do to get it to this point. It was not my intention to bring you guys on a step-by-step, super long video process like we've done with the Lion and other things. I want to get this machine up, running, and kind of be done with it. But like a lot of things, it always takes longer and goes deeper kind of than you expect. And this still is not going to become a full restoration. You know, I'm going to paint it by hand, I'm getting it functional and getting it done. However, with that being said, we are going to take the time to correct issues that we encounter. So it's going to take longer. And in doing that, I realized after talking with Josh Topper specifically that people probably do want to see some content on this more than just one video of me kind of telling you what I did. So good news for you guys, and more so Josh just kind of saying, hey, make videos because there isn't anything on this. So we're going to wrap this video up, you know, kind of as it is. I didn't really show much. It was mostly talking. But we're going to do a series of videos. It's not going to be like 30 videos like with the Lion, but maybe 10 or 5 on the repairs that I'm doing on this, and I'm going to break it into sections to make it very palatable. So the next series of videos is going to be on repairing these parts. It will be very interesting. There will be 3D printing, laser cutting, you know, working with cast iron, maybe some rotary braze welding, silicon braze. So there's going to be a lot of interesting stuff in that series of videos, and I'm going to do a video on that. And then Josh has a bad bearing over here in the gearbox, and he's been neglecting it, and so he's trying to get me to do a video on changing that bearing. And if I'm going to change that bearing, I might as well just work with the gearbox. So we might do a video on this gearbox and that gearbox. There may be a video on the table, what we do over there. I don't know. We'll kind of see how it develops. But from this point on, I'm going to go ahead and just do individual videos on each kind of repair we do, so you can kind of come along with me and see. And hopefully we can get this done in a somewhat reasonable manner and get an awesome working machine. So if you guys have enjoyed this video, let me know down below in the comments. I'm super excited to get this bad boy running and running well, and we will see you in the next videos to tackle these broken parts.